Hello again. In this video, I'm going to go over this homework problem from section 3.1. On this particular problem, there's two things we need to do. The first thing we need to do is to find the slope of the tangent line to this function at this particular point using this formula. And after we do that, we're going to find the equation of the tangent line to this function at that particular point. Okay, so let's find the slope of the tangent line first using this formula. So in this formula, A is equal to 1, because that's the point at which we're trying to find the slope of the tangent line. So let's plug 1 in for the A. Okay, and of course we're going to have to evaluate this limit. But in order to evaluate this limit, we're going to have to figure out what f evaluated at 1 plus h is. So I'm going to figure that out on the side. So f evaluated at 1 plus h. Well, this is f of x, right? And so we're plugging this number into the function. And so the question is, what does f do to a number that you plug into it? So for example, f of 1, which we're going to calculate here, means that we need to plug a 1 in to this x value here. And of course, when you plug a 1 into there, you get 1 over 5. That's why this point is 1 comma 1/5. So what happens if we plug in 1 plus h? Well, then we're just going to get 1 over 3 plus 2 times the number that we plug in. And the number we're plugging in is 1 plus h. Okay, and so let's just distribute the 2 here. So you get 2 plus 2h, and then the 3 sits in front. And of course, you can add those together and you get 5 plus 2h on the bottom. Okay, so that's f evaluated at 1 plus h. Okay, minus f evaluated at 1, which again, if you plug a 1 into here, you get 1/5. And all that is divided by h, and we're going to find the limit of that as h goes to 0. If you try to evaluate this limit using substitution, notice that you get 1/5 minus 1/5 on the top, which means it's approaching 0. And then, of course, the bottom is approaching 0 as well. So in other words, as h is getting closer to 0, the top is getting closer to 0 as well as the bottom. So you have this indeterminate form of 0 over 0. And that means that we have to change this to a different form in order to use substitution to evaluate the limit. Okay, I think the key here is we need to get a common denominator so that we can add this fraction, or actually subtract the fraction. Okay, so the least common denominator in this case would be a combination of these two factors. So you need a factor of 5, and you also need a factor of 5 plus 2h. Okay, so this is missing the factor of 5, so we're going to force that in by multiplying by 5 over 5. This has to equal 1 because you can't change the value of the fraction. So that's why I'm multiplying by 5 over 5. Okay, then over here, let's multiply by 5 plus 2h over 5 plus 2h, because you're missing that factor over here. Then we'll now have this common denominator, 5 times 5 plus 2h. Then notice on the top here, you're going to be left with 5 minus 5 plus 2h. Of course, this has to be put in parentheses because you're subtracting the entire thing. Okay, so let's go ahead and distribute that minus sign. And that's going to leave us with 5 minus 5 minus 5 minus 2h. And of course, those 5s are going to cancel. And that's just going to leave us with a minus 2h on the top. Okay, so now let's try to evaluate this limit using substitution. We still have to divide this by h. This is divided by h, and this is divided by h. So I left this h off. Okay, so if you try to evaluate this using substitution right now, you'll get 0 over 0 still. So it's still in an indeterminate form. The way to fix this is when you divide this by, you have a fraction divided by another fraction, you can flip this bottom one and multiply by it. So let's do that. So you can flip this, right, and make it 1 over h, and then you multiply by that. And then these h's will now cancel out. And then it becomes determinable. You're left with a minus 2 on top, and then this 5 times 5 plus 2h on the bottom. And if you substitute 0 in for the h, because h is getting closer to 0, then you're left with 5 times 5 on the bottom. So your slope, the slope of your tangent line, is minus 2 over 25. Okay, so that's part A. That's the slope of the tangent line to the function at this particular point. Now, let's actually find the equation of the tangent line at this particular point. Now we know the slope of the line, the tangent line, and we know it goes to this particular point, so we can use the point-slope formula. Okay, so m is the slope, right, minus 2 over 25. And then x1 is 1, and y1 is 1/5. And then we could just maybe simplify this. Let's distribute the negative 2 over 25. To the x and to the 1. Of course, when you distribute to the negative 1, really, you get a plus, because you have a minus times a minus. And then we get to add this 1/5 to the right-hand side. And of course, you're going to need a common denominator here in order to add these. So let's multiply this by 5 over 5. So we have a common denominator of 25. Okay, so now we're left with 2 over 25 plus 5 over 25. And so that gives us 7 over 25. Okay, so that would be the equation of the tangent line to this function at that particular point. Okay, I hope you found this video helpful. Thank you for watching.